Every fall, Americans drink more than 300 million gallons of apple cider, according to the USDA. That is enough liquid to fill over 450 Olympic swimming pools. The drink looks darker and cloudier than clear apple juice because tiny apple fragments remain inside. But behind this seasonal comfort is a fast industrial process. Trucks unload tons of apples within days of harvest, and machines begin their work at once. Apple cider has roots that stretch back to the first European settlers in North America. They brought apple seeds and the skill of pressing fruit into juice. By the 1600s, cider had become a common drink in New England, where clean water was often hard to find. Families pressed apples each autumn, storing the liquid in barrels for the long winter. In the 1800s, cider stood at the center of American farm life. Children carried it in lunch pails, and adults drank it at harvest festivals. At that time, the word cider usually meant a fermented drink with alcohol. The version we know today as sweet cider became popular later, especially after the Prohibition era. Over the decades, cider shifted from wooden presses on family farms to steel machines in large factories. What was once a homemade staple is now produced on an industrial scale. But how do millions of apples become cider inside a modern plant? The journey begins with truckloads of freshly harvested apples arriving at the mill. Within hours of unloading, workers guide them into a large water pit. The apples float to the surface, and the water current carries them onto a conveyor. The motion is steady, creating a stream of fruit that seems endless. Next comes cleaning. A washing station sprays jets of water while the apples roll across stiff brushes. This step removes soil, leaves, and any debris clinging to the skin. The sound of brushes scrubbing mixes with the hiss of water, filling the plant with constant noise. A single washing line can handle several tons of apples per hour. By the time they reach the end of the brushes, each apple is clean enough to be crushed without adding unwanted dirt to the cider. The apples now head toward the grinder, where their true transformation begins. But what exactly happens when solid fruit meets industrial steel teeth? The apples tumble down a chute into a powerful grinder. Inside, rotating steel arms push the fruit against sharp grates. The blades shred apples into a wet pulp known as pomace. Nothing is removed at this stage, so skins, stems, and seeds all become part of the mixture. The result is a slurry, thick with juice and bits of apple fiber. This pulp collects in a funnel at the bottom of the grinder. From there, high-pressure pumps push the mixture through stainless steel pipes. The liquid mass travels across the plant, destined for the press where juice will be extracted. At the press, the apple pulp flows between two wide, porous belts. These belts loop around heavy rollers, pressing tighter as they move forward. The constant pressure forces juice out of the pomace, while fibers remain trapped in the cloth-like material. Clear streams of juice drip through holes in the belts and fall into large stainless steel pans. The faint scent of apples fills the air, while the noise of rolling belts creates a steady rhythm. One industrial press can yield hundreds of gallons of cider per hour. The pomace is flattened and nearly dry by the time it exits the press. This leftover material is collected for later use, sometimes turned into animal feed or cooked down for apple butter. The juice, still full of fine particles, is pumped into a storage tank. Here, it waits for further filtering. But how can cloudy liquid become safe enough to sit on grocery shelves for months? From the tank, the raw cider passes through a rotating drum with tiny perforations. This filter removes pits, stems, and large bits of pulp. The liquid seeps through the drum's surface and flows into a wide trough. The cider is still cloudy, but only fine sediment remains. The cider travels through thin channels between hot steel plates. This is essential because natural yeasts in apples would otherwise convert sugars into alcohol. By applying heat, the cider remains non-alcoholic and safe to drink. Workers load rows of empty plastic jugs onto a conveyor. Nozzles descend from above and release streams of hot cider into each container. The jugs are filled completely to the brim. This leaves no room for oxygen, which can cause spoilage. The filled jugs glide forward to the capping station. The seal is airtight, locking in heat and extending shelf life up to 1 year. The finished product now looks ready for the supermarket shelf. But what other everyday foods hide similar factory secrets waiting to be uncovered? Factories can produce up to 150,000 chocolate coins in a single day, according to the National Confectioners Association. That number is enough candy to fill thousands of Christmas stockings or brighten Hanukkah celebrations across the country. These shiny treats look like money, but their value comes from tradition and taste rather than spending power. Each coin begins as a massive chocolate bar that weighs 10 pounds. Machines melt, temper, and shape it with exact precision before wrapping it in gold foil. But how does a simple block of chocolate transform into edible money that carries so much holiday meaning? Chocolate coins trace their story back to Europe in the late 19th century. They appeared as festive tokens during Christmas, linked to the legend of St. Nicholas. Families would slip them into stockings as symbols of charity and good fortune. At the same time, Jewish communities began using them during Hanukkah to teach children the value of money and generosity. By the early 20th century, chocolate coins traveled across the Atlantic and entered American holiday culture. Factories started producing them in bulk, wrapping solid chocolate discs in gold foil to resemble real currency. They quickly became a seasonal favorite, tucked into mesh bags that children could hold and shake like treasure. Over time, the designs expanded beyond pennies and nickels to include poker chips and novelty patterns. Yet their charm remained the same, a mix of sweetness and symbolism. But how does a solid chocolate bar turn into stacks of shiny coins rolling off the line? The process begins with giant chocolate bars that weigh about 10 pounds each. Workers load them into a large kettle designed like a double boiler. Hot water circulates inside an outer shell, slowly melting the chocolate without burning it. The smell of warm cocoa fills the air as solid blocks turn into a smooth liquid. This kettle can hold up to 2.5 tons of chocolate at one time. Mechanical paddles inside stir the mass, keeping the temperature even. The liquid is thick but flows easily once fully melted. Pumps move it through stainless steel pipes across the factory floor, carrying a stream of molten chocolate ready for shaping. The machine keeps the chocolate at a steady temperature, which is crucial for the next stage. Now the chocolate is ready to be tempered. But how do machines create the perfect shine and snap that every chocolate coin must have? Tempering is the stage where chocolate gains its glossy look and firm texture. The melted chocolate flows into long pipes that pass through different cooling zones. Each section lowers the temperature by a few degrees until the crystal structure of the cocoa butter stabilizes. When it leaves the pipes, the chocolate is thick but not yet solid. A wide blade spreads it evenly across a moving conveyor belt. The sheet then enters a refrigeration tunnel about 15 yards long. A spring-loaded die press stands at the end of the line. It works like an oversized cookie cutter, punching circular blanks out of the cooled sheet. Each cutter is tubular, allowing the round pieces to stack up inside the device. The leftover lattice of chocolate does not go to waste. Sheets of thin gold foil feed into the wrapping machine. Tension rollers stretch the foil to an even thickness, preparing it for the coins. The wrapped coins move forward into a die press. The machine stamps designs onto both sides, pressing through the foil and leaving a permanent mark in the chocolate beneath. Designs can show American pennies, poker chips, or special holiday symbols. The embossed coins slide down chutes onto another conveyor. Here, they spill into large bins where automated scales weigh exact portions for packaging. Once the target weight is reached, the coins are funneled into mesh bags. But what other familiar candies hide factory secrets that turn tradition into mass production? Americans eat more than 90 million pounds of marshmallows every year, according to IBIS World. That is enough to cover over 1,500 football fields in fluffy white candy. Marshmallows look light and playful, yet behind them stands a precise industrial system. From simple ingredients like corn syrup, starch, and gelatin, factories create billions of soft pillows that hold their shape for months. For many people, the candy brings memories of campfires, s'mores, and holiday desserts. But inside the factory, the process is far from simple. How do machines whip air into sugar and turn liquid into cubes of chewy sweetness? Marshmallows trace their roots back to ancient Egypt more than 3,000 years ago. At that time, candy makers mixed honey with sap from the mallow plant, creating a chewy treat reserved for nobles and gods. The plant grew in marshy ground, which gave the sweet its lasting name. In the 1800s, French confectioners replaced plant sap with whipped egg whites, sugar, and gelatin. This formula created a lighter texture and made marshmallows easier to shape. By the early 1900s, the candy reached America, where it quickly found a place in cookbooks and dessert tables. Families used marshmallows in ambrosia salads, gelatin molds, and holiday pies. The biggest change came in the 1950s with the invention of the extrusion machine. It pumped marshmallow paste into long ropes and cut it into pieces, allowing mass production. From then on, marshmallows became a symbol of American campfires and childhood snacks. But how do modern factories transform syrup and gelatin into billions of fluffy cubes each year? Factories measure out corn syrup, sugar, starch, water, and gelatin with precision. Each ingredient is stored in large stainless steel silos, where automated systems release exact amounts into mixing tanks. Accuracy is key, because even a small mistake can ruin the texture. Corn syrup provides sweetness and keeps the candy soft. Starch helps with structure, while gelatin gives the marshmallow its famous bounce. Dry powders flow down chutes with a steady hiss, while pumps transfer liquids through thick pipes. Inside the mixing tank, giant paddles turn slowly, folding the ingredients into a sticky base. The mixture is pumped into steam-jacketed kettles that heat it to 240 degrees Fahrenheit. This stage cooks the sugar, creating a uniform syrup. Sensors inside the kettles track temperature and pressure to avoid burning. Steam rises from the vents, and the sound of boiling fills the production floor. The syrup must be consistent, without crystals or lumps. To achieve this, it is pushed through fine mesh filters. These sieves catch stray grains of starch or clumps that could disrupt texture. The filtered syrup flows clear and glossy, with a light golden tint. The syrup enters massive industrial mixers, where speed makes the magic. Blades spin at thousands of revolutions per minute, whipping air directly into the hot liquid. The roar of the machines is constant, and the mixture begins to grow in volume. At the same time, gelatin is added in liquid form. Heat activates its binding power, locking bubbles of air inside the mixture. The syrup doubles or even triples in size as it thickens into marshmallow batter. Its color shifts to bright white, and the texture becomes foamy yet stable. The whipped mixture is pumped into extrusion machines under high pressure. Long nozzles force the foam out as continuous ropes, each one smooth and glossy. A conveyor belt carries the ropes forward in neat rows. Cooling fans blow across the surface, helping the ropes set while still pliable. Some machines press ropes together to create colorful twists, while others shape them into wide slabs. Sharp rotary blades slice the ropes into uniform cylinders, each piece dropping in rhythm onto the belt. Factories can cut thousands of pieces every minute, producing more marshmallows in an hour than a small bakery could in a year. The floor is busy with motion, from the hiss of air pumps to the snap of blades. Freshly cut pieces are still sticky, so another step is needed to keep them from clumping. How do factories coat each marshmallow so it stays smooth and separate inside the bag? The marshmallows tumble into large rotating drums. Samples are pulled from the line for the snap test. Workers cut a marshmallow in half and press it together. If it springs back to shape within seconds, the batch passes. If not, adjustments are made to mixing or gelatin levels. Approved marshmallows move to the packaging line. Scales measure exact amounts, dropping them into bags made from heat-sealed plastic film. From syrup and air, the factory has created millions of fluffy cubes in a single shift. And as they leave the plant, one question remains. What other everyday sweets hide such complex systems behind their simple shapes? From orchards pressing apples into cider, to machines stamping chocolate into coins, to mixers whipping air into marshmallows, every product hides a story of precision and scale. Each one begins with simple raw materials, yet factories turn them into symbols of culture, holidays, and memory. The smell of apples in autumn, the rattle of foil coins in a stocking, and the softness of a marshmallow at a campfire connect us to moments we never forget. Behind these small joys stand powerful machines, steady rhythms, and workers guiding the process. Seeing the systems makes us appreciate how much effort hides in everyday treats. So now the question is yours. Which factory process surprised you most today? And what product should we uncover next? Share your thoughts in the comments. And if you enjoyed this journey inside the factory, subscribe to Captain Discovery so you never miss the next story.